Well, folks, welcome back. For those few of you that are actually watching these videos, I hope somebody finds them. The intent of these things is not for me to, benefit from it so much as to help guys that might be wondering whether to get into this, or they might be struggling with this stuff in school, whether it's in college or it's in trade school and understanding electricity. But the intent of me doing this is strictly for you guys. So anyways, let's get to it. Today is going to be about parallel circuits. We've already done series circuits, and series circuits they're the end state that all circuits have to be turned into for you to find your circuit totals and your current, your resistance, your voltage, your power. In series, it's pretty simple. You take your resistors, you just add them all up. There's nothing really complicated about that. That gives you your resistance. And remember, any two pieces of information, whether it's your voltage, the resistance, the current, or the power, any two of those four pieces of information, we can find the whole thing out. But when we get into the parallel circuits, it's a little more complicated, but it's not difficult once somebody takes the time to explain to you. That's what I want to do today. And just like I've said before in the series circuits, you got to know the rules. If you don't know the rules, you cannot play the game, and you will be very frustrated. I use the analogy of when we grew up as kids playing sandlot baseball or football or whatever floats your boat. And you play the rules in your neighborhood, and you guys are pretty doggone good. And then you go over to your buddy's place on 3-4 blocks down, and they don't have the same playing field. They don't have the same rules. And in your rules, you're beating those guys, and they say no, that doesn't count. You stepped out of bounds here. You hit the ball over in Mrs. Smith's yard, you're automatically out. Whatever the case may be. In that example that we learned as kids, if we don't know the rules, we can't play the game. So we're going to go ahead and get to this. So parallel circuits are when you have your resistive loads or your loads of whatever type. They're side by side, if you will, kind of like going down the interstate. You might go through, like when I go to Nashville, there's places at the 24-65 split that are 5 lanes across. And we're all going in the same place. Some go a little faster and some go a little slower. But very, very similar in that, the traffic can go in different paths. Whereas a train on the same tracks, he's pretty much, those cars can't pass each other, or otherwise they're going to have some problems, okay? So let's go ahead and start with the rules for this today. So the number one rule that you need to understand, that for a parallel circuit, that it is a current divider. And when we start getting into these next rules, you can see that I've already pre-written up here. You'll see how that works, and you'll really see it when we start when I do the video on how to figure these things out, okay? So the number two rule is your voltage stays the same. In a parallel circuit, your volts do not change. And there's a couple of examples that you guys deal with this on a regular basis. If you if you take a voltmeter and you check the voltage anywhere in your house, in the regular household outlets, you're going to get 120 volts. Now, it doesn't matter where it is, whether it's in the kitchen, in the bedroom, in the garage, they're all just the regular outlet. I'm not talking about a 240 volt, for your dryer or something like that. But when you check those voltage, it's going to be a nominal 120 volts. Might be 117, might be 121, but it's going to be in the 120 volt range. But the current that is allowed to happen in the bedrooms are typically maxed out at 15 amps. On the other hand, the currents that are allowed in the kitchens, you got to have at least two 20 amp separate counter circuits. It's National Electric Code required. So you can have, it's dividing the 200 amp service, which is a typical residential service, will have 200 amps coming into it, and it's divided. You have 120 volts going throughout the house. You have 240 volts total coming in off that transformer, off your pole or off the pad mount, coming into your panel. And then it's all parallel circuits after that, okay? So everything that gets plugged into this room right here where I'm at, there's 4 plugs. There's one on each one of these walls. Everywhere I plug in, I'm getting 120 volts. But if I plug in, maxed out at 15 amps, if I plug in something on this wall, it's 5 amps, something on this wall, it's 5 amps, there's 10 amps gone. And if I plug something in on this one here, now I'm in the 15 amps. I'm right on the cusp. If I plug something in on the next wall over, I'm probably going to have my circuit breaker tripped because I'm over current on that. Okay, but we'll get into that, kind of stuff later. But my point is, that's one of them. The other one is your car. Everywhere you check on your car, you're going to get 12 volts DC on that. In the residence, it's AC voltage. But, your headlights are in parallel. Your taillights typically are in parallel. And you're getting 12 volts throughout that. But the current is what gets divided throughout that. Okay. Sometimes you might find some problems when you start hooking up, your speakers, and you hook up some extra, bigger amplifiers and stuff like that, and the stuff doesn't work right. That's because you're starting to stress the system. You're dividing and dividing and dividing until a point where there's nothing left to divide. There's not enough current in there. It's been divided out. You think about a piece of pizza. If there's 15 slices of pizza and everybody takes their, there's 10 guys and everybody takes 2 pieces, you run out of pie after a while and there's no more left. So just another example. So our next one, current changes. And then 3A, all of the current drops must add up to the current total. That's what the IT stands for, okay? So all of your current, we just kind of talked about the examples with that. This room is a 15 amp room. I've only got 15 amps to work with. If I take 20 amps out of it, I'm going to trip a circuit breaker. That's a safety device to protect not you, but the house, okay, so it doesn't burn down. All right. Number 4, resistance total. It can never be larger than the smallest resistor. So if we've got 2 resistors, let's say one is 4.7 mega ohms. That's 4.7 million ohms of resistance, ridiculously high. Okay, and you've got another one that is, let's say 100 ohms resistance. Our resistance in that circuit will never be more than 100 ohms. It won't even be 100 ohms. It might be 99.999 and 9 decimal points. But whatever that is, it'll never be the 100, okay? So when you're starting to do your math, what that's going to tell you is if your math comes out bigger than your smallest resistor, you didn't do something correct, okay? It's that simple. And that's just a quick check. And, QA, QC, as they refer to in industrial manufacturing, quality assurance, quality control. You do your math on that. You got an answer that you came up with through Ohm's law, and that answer, and use our 4.7 meg and our 100 ohm resistor. If we get one that's 120 ohms, we didn't do something correct. Okay, it's not saying that you're wrong. It's just saying, hey, your math, you've done something wrong. You might have fat fingered it. I got big hands. I fat finger it all the time. On my calculator, you might have put a decimal in the wrong place. But there's numerous things, but it's just your numbers didn't come out right. And if it didn't come out right, just rework your numbers. Okay, I've showed you before how you can use Ohm's law to check your work. Okay, so just know, never larger than your smallest resistor. Okay, so now number 5, to find your resistance total. There's a couple of different ways to do this. We're gonna talk about C here. Ooh, you guys can't see that. Let me bring that down here. Okay, C. If all resistors are the same, okay? And what I mean by that is let's say you got 3 resistors and they're all 5 ohms. You're going to take 5 and you're going to divide it by the number of resistors that it's there. So you're going to take 5 ohms, divide it by 3, and that's going to be your answer for your circuit total. Okay? That's if all the resistors. And if there's 20 of 5 ohm resistors, if there's 100 of them, you're going to take 5 ohms and divide it by 100. If there's 3 of them, you're going to divide 5 by 3. If there's 2 of them, you're going to take the 5 and divide it by 2. Okay, very, very simple. So you don't have to stress about that if they're all the same resistance. Okay, now the one that they typically introduce you guys to when you first get into parallel circuits is this formula right here: R1 times R2 divided by R1 plus R2. Okay, and that's a very simple one. The problem with it is it's not efficient. It will work just great if you've only got 2 resistors, but if you've got 4 resistors, you've got 3 resistors, you can still use this technique, but you're going to have to find the resistance of the 2, and then you have to do this again to bring that next resistor into the equation, and it just is a long, drawn-out process. Okay, and it's not necessary. It's all right to I guess to kind of break the ice, but I found in teaching this stuff that if I teach it to you the first time, how I'm getting ready to show you on letter B right here, because B you can use for 2 or 1,000,000. It doesn't matter how many resistors you have, if you understand how this works. And if you're not as familiar with algebra and stuff like that, don't sweat that. It's basic, simple stuff when you break it down like we're getting ready to. Okay, the next technique is 1 divided by, let me get this correct here for you so I don't confuse you. You're going to take resistor 1, and you're going to take 1, the number 1, and divide it by that resistor. And then you're going to take the next resistor, and you're going to take 1 and divide it by that resistor. And the sum of those two, you're going to add those together. And then you're going to take that sum, and you're going to take 1 and divide it by the sum of that you came across. Now it's referred to as a reciprocal method. It's just a fancy way of saying you're going to divide 1 by these answers, okay? If we had a 5 ohm resistor, we're going to take 1 and divide it by 5. All right, and that sum, we're going to add that to, let's say our next one is 10. We're going to take 1 and divide it by 10. And the sum of that, we're going to take the sum of that and the sum that we got from R1, and we're going to add it together. Now, once we get those together, then we're going to take 1 and divide that by the sum of those two that have been added together. And if I've got my example down here for you guys. Oops, let me move this down here for you. My example is just for 2. We could have 3, we could have 50. No limit to it. You still, when you do your R1, reciprocal R1 plus R2, and so on and so forth, you get all those numbers, you got to do that last reciprocal of that. You got to take that number 1 and divide it by the total sum of all of those resistors. And I'm going to do another video specifically on how to do this stuff here. The intent of this is just so you guys understand this. And the beauty of this video is you can sit here and you got to listen to me keep repeating this. You can I've got this part good, Mike. I'm just going to go to the next part here and I'm not getting this. You can rewind that 1,000,000 times. And I've done that on YouTube videos when I was learning how to play guitar. Okay, you don't aggravate your instructor. You don't feel silly or anything like that. Me personally, you should never feel silly asking a question on something you don't understand. That's what an instructor's, that's their job, is to help you. Okay. Again, these are the simple rules. This video is going a little longer than I'd like. We're at 12 minutes right now, but it's parallel circuit is a current divider. Okay. Volts stay the same in this. So when you start doing your math, if it's a 24 volt DC circuit in parallel, you get 24 for your circuit total. You're going to bring that down automatically. They're going to be all the same. Okay. Current is what changes, and all of your current drops must add up to the current total in that circuit. Okay, and then to find your resistance total, you can do R1 times R2 divided by R1 plus R2. You can do the resistor divided by 1 plus resistor 2 divided by 1, and then do the 1 divided by that sum. If all of our resistors are the same, we're going to just take one resistor out that are the same, and we're going to divide it by the total number of those resistors. And that will give us our circuit total on the resistance. Okay. If you have any questions on this piece here, please shoot me, put me a text. It sends it to my phone, and I will gladly make another video for clarification, because if you don't understand, I can guarantee you there's more people than just you. And nobody starts off in life understanding how this stuff goes. Someone who might have a math background might understand a little better, but I'm telling you right now, don't sweat it if you don't understand this. I will help you out. I promise you and I assure you. Okay, I enjoy what I do with this stuff, folks. So please watch this video. Share with your friends if they're struggling with it also. Sometimes people are a little proud and they don't want to say that they're struggling with something. But please share this. This is done out here to help you guys get out in the world, because there's too much of a need for electricians, and there's too damn much money out here they're willing to pay you to chase the blue dragon, if you will. Okay, fellas and ladies, it's all inclusive. So everybody stay safe out there, and not hugging a tree safe, but just keep your head on a swivel and be aware of your surroundings when you're out there in the field. And I'll see you guys next time.